Okay, good morning. Welcome to the class. Okay, so today we will continue our discussion on these valid argument forms, and then we will talk about some examples. Okay, so we have introduced some very common valid argument forms last time, such as the Modus Tollens, and then the hypothetical syllogism. So there are many that we have introduced. And then these are so simple and common that we usually call them rules of inference. So they are used as rules to help us to draw inference. Drawing inference means making new conclusion. Okay. So for today, we will look at some example, and then we will need some English translation, and see if we have some premises told in English form. Can we arrive at a new conclusion about some sentence? Okay, but because we need English, okay, so there are many statements of the form like this: P implies Q. So I think I should introduce some of the various ways that we can talk about this P implies Q in English. So first of all, the simplest way to show P implies Q, so to say about P implies Q is to say if P then Q. Is that okay? So it's like if it rains, I drive to school. Okay, then P is it rains, and then Q is I drive to school. Is that okay? Now there is another strange way to say this. We can also say P only if Q. Is that okay? Okay, so only if you can translate this to imply. Or is that okay? So this is a strange way to say this. But later you have more feeling about why we call it only if. We can even say Q if P. So we can exchange the order of these two. Q happens if P happens. So it means if P happens, Q happens. Is that okay? Is that okay? So all of these are the same way of describing P implies Q. And there are two more. So we will say P is a sufficient condition for Q. And then we will also say Q is a necessary condition for P. So this sufficient and necessary, they are very confusing. Perhaps I will give you an example. Like if I have a lot of money, it is sufficient for me to have many great food this month. Okay? So the money is sufficient to give me very good food. So if I have money, implies good food. So that means what? Which one is giving me something that I can be happy, sufficient? It is the money. Is it okay? So this part P is the sufficient thing that we have. And once we have this one, we will automatically have Q afterwards. Is that okay? Okay, so that's why you think of this as sufficient. And then why we say Q is a necessary condition for P. Okay, if you look at it, it means that without Q, then P will not happen. If you believe that P implies Q to be true, if you believe that I am always following this rule, if it rains, I drive to school, then if you do not see me driving to school, then it means that it cannot be raining. Is that okay? So that's why Q is necessary. Without Q, there is no P. Okay? So there is the Romeo and Juliet story. Romeo. So near the ending, Juliet pretended to die, and then Romeo didn't know. Okay, so Romeo saw Juliet dying. Okay, he drank some poison and then killed himself. Okay, and then Juliet woke up and then found that, oh, Romeo is dead next to her. And then she says, I can't live without you. So Juliet says, okay, so this is Juliet. She says something like, I can't live without you. Something like this. Is that okay? Now, so we can think of this as there are two things that we talk about. We can talk about Juliet lives. This is one thing. And then Romeo lives. This is another thing. Okay. So which one is a necessary condition according to Juliet? So Juliet says, I can't live without you. So is Juliet lives a necessary condition for Romeo to live, or is Romeo to live a necessary condition for Juliet to live? This is, okay, this is necessary, okay? Because Juliet says, I can't live without you. Without Romeo living, then I can't live, okay? So this is necessary. This is sufficient, okay? If Juliet lives, it is sufficient to know that Romeo must be living. Is that okay? So in this case, this is this one. Of course, had Romeo not dead, okay, then Romeo may be saying something like this. In that case, Romeo may say, I can't live without you. Then in that case, this Romeo living is a necessary and also a sufficient condition for Juliet living. Is that okay? Okay. So usually this one is, we have defined what is necessary, what is sufficient. If it is a double arrow, if and only if. So we call this if and only if. For the if and only if case, any one condition will be necessary and sufficient for the other one. Is that okay? Okay. Now, if you understand everything so far, so this is time to do some exercise. So let me define some sentences first, okay? So P, let's say P, I don't want to write a lot of things again and again. So that's why I try to capture some sentence using a variable. So this is a proposition. It is sunny this afternoon. Okay? And then let's say Q is today is colder than yesterday. So today is colder than yesterday. And then R is something like we go swimming. And then let's say S is we play basketball. Okay, so how do basketball? Okay, we play basketball. And then T is we go home early. Okay, so all these are sentences that are defined. And then we have some premises given. And then we hope to get some target conclusion in the end. So this is our target. We want to get some target conclusion in the end. Let's see if we can do so. Okay, so first of all, what are the premises? So I will read it out to you, and then you see if we can translate this into some logical formula. So first of all, the first premise that we have is, it is not sun. Okay, so this is the first premise. The first premise says, it is not sunny this afternoon, and it is colder. So how do we translate my sentence into this PQRST? So let me read it out again. It is not sunny this afternoon, and it is colder. So what should it be? So it is N, right? It's not sunny this afternoon, so not P. Very good. So it is not sunny this afternoon, and it is colder. So this is not P and Q. Is that okay? So this is the first one. Now we also know the next one. The next one is, we go swimming only if it is sunny. We go swimming only if it is sunny. So what is it? Only if. So is it R implies P or P implies R? Sunny, right? R, once again, okay. We go swimming only if it is sunny. Is it R implies P or P implies R? Oh, very good. Okay, so this is R implies P. Okay, the third one is if we do not go swimming, we will play basketball. If we do not go swimming, no swimming, then we play basketball. So it is not R implies S, right? Yeah, I may be wrong. Okay, correct me if I'm wrong. Okay, so it is not R implies S. And then the last one, we have four of them. If we play basketball, we go home early. So it is S implies T. Okay, S implies T. And the target conclusion that we want to have is T. We don't know whether this is true or not, but then we want to prove that we can draw this conclusion. Okay? So how do we draw a conclusion? So if we still remember, drawing a conclusion means we may assume each of these premises are true and then see if the conclusion can be made according to some valid argument forms. So if this is, so I'll show you an example, okay, how to do that. So we're actually using the premises. First, these are something that we know that are true, and then use some rule of inference to get some intermediate conclusion. Now, because the premises are true, the intermediate conclusion will be true. And then we can reuse the new intermediate conclusion as premises so that we can continue to draw more conclusions. Is that okay? So this is the idea. So we start with something that we know so that we know a little bit more. And once we know a little bit more, we can use the result of that one to know a little bit more. So more. And then in the end, hopefully, we hope to get this T. Is that okay? Okay. So let's see. So usually a proof, we have some step here, and usually we will need to explain why it is true. Okay. So what I'm writing here on the left-hand side here will be something that is known to be true. Okay. If in the end we have a T here, then we are very happy. And then the reason is to explain why you get each step. Okay. So there is a typo here in the slides. There is no typo that we're writing here. Okay. So not P and Q. Sorry for the mistake. Okay. So the first one is not P and Q. What is the reason? The reason why this is true is because it is the premise. We assume that the premises are all true. Is that okay? And then not P and Q implies not P. Okay? Because we know that not P and Q is true, then automatically not P has to be true, right? This is due to some rule we have studied last time. So I copied it. It's called simplification. So it is a simplification. And to make it more clear, so it is a simplification of this step 1, the result of step 1. Okay? And then after that, we can write down R implies P. So what is R implies P? So this is, again, from the premise. Okay? And then we can get not R. So why we can suddenly get not R? Why? Because we know that not P is true, and R implies P is true. So what does it mean? So R cannot be true. If R is true, then we have true implies false. Then this is not correct, not true. So the only condition that we can, so based on 2 and 3, we can get not R. Is that okay? And actually, this is another rule that we have. This is the method of denying. So if I eat a cake, my mouth will be dirty, and then I'm very tidy now, so I didn't eat the cake. Is that okay? So this is another name. So this is called Modus Tollens. And then you will be using, so write down, so you use 2 and 3 to draw this Modus Tollens. Is that okay? And then you simply get what we have. So the fifth one that we have is, let's say, not R implies S. Is that okay? Not R implies S. So this is again from the premise. It is again from the premise. And then suddenly we can have the next step is S. We have not R implies S. So we must have S. Okay? So this time it is the modus ponens. Of this 4 and 5. Okay, there is not enough space, but I believe you understand. So now we have S, am I correct? And then the next one, we can say we will have S implies T. This is from the premise. We have S implies T, then we will have T. This time it is again from modus ponens. Is that okay? And done. This will be, we call it a proof, okay? A proof. And then actually this proof is so simple, so simple in format that the things on the left-hand side are always chosen from your premise or from some intermediate conclusion that you can have. And the right-hand side are based on only the rule of inferences that we have studied. So long time ago, we can actually write long time ago, people started to use computer to do this kind of logic checking. Okay, so you just plug in a lot of premises, and then you check, you plug in a conclusion, and then you want our computer to check whether the premises can lead to the conclusion. Okay, so this is a topic that has been studied for a long time. So this is called automated theorem proving. So we prove a theorem, or we can also call this mechanical proving, because you just need a computer. You don't need your brain to work. Once you type your program correctly, then the computer will help you solve this problem. And then, although it has been developed for a long time, it is still used nowadays. Because if you can relate, logic and circuit are very closely related. Okay, so in a very large circuit, we still need to check whether a certain part of the circuit is doing what we want. So for different kinds of input, do we get the correct corresponding output? And this one, we still need computer to help. So this is the one of the things that logic can help in real life. Okay? Okay, let's talk about another. Okay. Okay, so here, let me write down again some of the notation for the sentences. So this time P is, you sent me an email. Okay, you sent me an email. Q is, I finished my program. And then R is, I go to sleep early. Okay. I go to sleep early. And then S is, I wake up refreshed. Okay. So these are the things that we have. And then, let's see. So I'm going to describe the premises in English. So what are the premises that we have? So the premises, the first one is, if you send me an email, then I finish my program. So this will be very simple, right? If you send me an email, I will finish my program. So this is P implies Q. Is that okay? The next one is natural. If you do not send me an email, I will go to sleep early. Yeah, this is natural, right? If I don't receive anything special, I will go to sleep early. So the next premise that we have, so I can use a comma to separate it. If you do not send me an email, so it is not P, then I will go to bed early. R. Is that okay? And then the next one is, if I go to bed early, then I will wake up refreshed. So I will have R, then it is implying S. Okay, now what is the conclusion that we can make? Let's guess, okay. So the conclusion is turn out strange, okay. The conclusion is, if I do not finish my program, I will wake up refreshed. Okay? So the conclusion here is, if I do not finish my program, so this is not Q, then I will have S. Is that okay? Let's see if we can do so. So we will have some step. We will have some reason. Okay. Okay, so there are many different ways of writing this. You do not need to follow the order. You can pick this one to use, or pick this one to use, or pick this one to use. As long as what you are writing down here, every conclusion, every mini conclusion, intermediate conclusion makes sense. You understand why it is correct, then everything correct, and then you get the end, it is a correct thing about not Q implies S, then it is perfect. Okay? So I'm showing just one way of proving this. This is not the only way. Okay? So for instance, step 1, I may just copy P implies Q here, and the reason is because it is the premise. Okay, let's see. Probably you will have P implies Q, right? And then, how come? Oh, okay. Let me see. Let me double check it. Yeah. So I have a lot of mistakes here. So, okay. So let's see. So I have P implies Q already, right? And then, okay. Now if I have P implies Q, then I will have not Q implies not P. Am I correct? Okay. So why is it true? We call it the contrapositive. So P implies Q is equivalent to not Q implies not P. We have actually done this as an exercise before. And then this is called contrapositive. Contrapositive of the first one, of this one. Is that okay? And now we get an easy life. Because we have not P implies not Q, and then we also have not P implies R. So this is from the premise. Then we will have not Q implies R. Is that okay? Because not Q implies not P implies R. Together, it is not Q implies R. Is that okay? So there is a name for it. So this is called the hypothetical syllogism. Okay? Based on these 2 and 3. Okay? Now you have not Q implies R, and then you can copy the premise R implies S into this proof. Then together we apply this. Is that okay? We apply the hypothetical syllogism again, and then we will have not Q implies S. And this is what we want. Is that okay? Is that okay? So if you are okay with the discussion so far, could you please raise your hand? Okay, excellent. Okay, excellent. Okay. Okay, one more. So we have not talked about using the quantifiers yet.